Let's do this question from your lab assignment from section 5.2. The graph g of x consists of two straight lines and a semicircle. Use it to evaluate this integral. So we have several integrals to evaluate, and it's going to go down here. So let's go ahead and take a picture of this so that we can refer to this graph. As we move along. Alright, so the integral of the graph from 0 to 4 is our first task. G of x is positive, then the integral corresponds to the area underneath the curve and above the x-axis on the interval from a to b. On 0 to 4, the function is above the x-axis, so 0 to 4, the function is above the x-axis here. And the area is equal to a triangle created by the function. So if we were to shade in this triangle, we would shade in this little area. See if we can shade that in. So this is the area that we can shade in. Well, we want to stay within the lines. Alright, so the right triangle has a side length of let's see, each of these is 2, 4, 6, 8. The length would be that they're measuring is across the along the x-axis, so that's 2, 4, so it's going to be 4 along the x-axis, and a side length of 8 along the y-axis. So basically the base is 4 and the height is 8. The area of a triangle is 1/2 base times height. Then the triangle area is has an area of 1/2 times 4 times 8. So 4 times 8 is 32, divided by 2 is 16. So thus this area is going to be equal to, or this integral is going to be equal to 16. So that part's complete. Our next step is to find the area between 4 and 12. So this is the semicircle. So the graph is a semicircle, and since the semicircle is below the x-axis, then this integral is going to be a negative of the area of the semicircle itself. Let's see what the radius of the semicircle is. It goes from 4 to 8 to 12, so I think that has a radius of 4. Once we have the radius of 4, we can find the area. The area of a whole circle is pi r squared. So pi and then r squared. So the area of our semicircle is going to be half of that. And so we'll just say 1/2 times pi r squared. And so our particular semicircle has a radius of 4, so let's go ahead and put 4 here. So this is 16. 16 divided by 2 is 8. So let's just say 8 pi. Alright, now remember that this is below the x-axis, so our final result for the integral from 4 to 12 is going to be the negative of the area that we found, so that's negative 8 pi. Okay, now the integral from 0 through 14, so we found the area from 0 to 4 and from 4 to 12. So now the area from 12 to 14 is going to be another triangle. So it looks like it's going to be this triangle, and that looks like it has a base of 2 and a height of 2. So 1/2 base times height And so the two twos would cancel, and then we will just have a 2 left over. And so we have an area of 2. We have an area of, what's our second area? An area of 16. So we have 16 and 2. We have 16 for this first one, plus 2 for this one, that's 18. And then we have this expression that gave us a negative 8 pi. And we can't simplify that anymore, so we'll just submit it as is. And then that's our problem.